I'm Sergio, and our subject for this session is statistics and probability. So, our source is this one, the Depth Ed Self-Learning Module. Let's have now mean and variance of discrete random variables. Let's have the key terms first for you to understand the concepts that I'm going to include in this specific lesson. Okay? Kindly consider first this situation. Okay? We will use this one to define terms that will be useful in understanding this lesson. So determine the expected value and variance of random variable below. We have here a random variable, capital letter X, and then the probability function. Okay, and we will define mean. So mean is actually the expected value. In discrete random variable, it is the central value or average of its corresponding probability mass function. We also have variance. Variance and together with the standard deviation are two values that describe how scattered or spread out the scores are from the mean value or expected value of the random variable. We also have discrete probability distribution. So when we say discrete, it is countable, meaning this distribution follows the idea of a discrete random variable, meaning this distribution has elements which are not continuous. Okay, they can be listed. Okay, they are countable. Let's have now this one. We will consider again this, but this time we will determine the expected value first of the random variable below. So we will find out how to compute the mean. Okay? For the expected value, I'm going to include also notes here so that I can write here some key points that you need to consider when dealing with expected value. Okay? We have this formula. Mean is denoted if it's a population, mu. So mu is equal to the expected value, okay, this one is equal to summation of x times the function where I starts from 1 up to n. We can actually rewrite this one as summation. Okay, by the way, I'm going to transfer that one in the notes. Summation of x times the function, which is the probability. Okay, the probability function. So you can use this formula, okay, which is a part of this to determine or solve the expected value. Okay, let's have it. So given your x, I would like to emphasize here the x is not the usual x, but the capital letter X, the random variable. So random variable here are this one, 0, 1, 2, 3, 4. And the probability function is 1/5, 1/5, actually all 1/5. Okay? And what you're going to do is just multiply. Multiply this one, 0 times 1/5, this one, 1 times 1/5, 2 times 1/5, 3 times 1/5, 4 times 1/5, and then summation here means you are going to add. Okay? Yes. And then you have this 0 times 1/5, that's 0. 1 times 1/5, that's 1/5. 2 times 1/5, 2/5. 3 times 1/5, 3/5. 4 times 1/5, 4/5. And then if you're going to add this one, this is similar fractions. Just copy the denominator. Okay? You have actually the denominator here 5 and then add the numerator. 1 plus 2, 3 plus 3, 6 plus 4, 10. And then 10 divided by 5 is equal to 2. And that's your expected value. You can state, therefore, the expected value of the given random variable is 2. Got it? Yes. Let's proceed with this. Determine the variance of random variable below. Okay, we are going to have a different example. But in here, you will understand how variance works or how to compute the variance of discrete random variable. Okay, let's have this. The same, the variance and the notes. Okay, so for the variance, this is denoted with the symbol sigma. Okay, sigma squared is equal to this one. The variance is equal to summation of x minus mu, that's quantity, okay, squared, times the corresponding function where I starts from 1 up to n. Or we can rewrite that one like this. Summation of, okay, quantity random variable minus, okay, the mean, you can have it the mu, okay, squared, times the corresponding function. Okay? And using this one, we can find, of course, the variance, and we can also find the standard deviation, okay, or usually known as SD, and that is, okay, symbolizes with sigma only. Meaning, if we are going to get its square root, you will have your standard deviation. Okay, we will proceed with the computation. So, first, you need to copy, just copy the random variable given, the 0 to 4, for your first column. For the second column, you will just copy the probability function. Just remember that you are going to convert this one into decimal. So 10% is just 0.1, 20% 0.2, 30% 0.3, and then 20% 0.2, and then another 20% 0.2. After this, for your third column, okay, you just need to multiply. Multiply the random variable and the probability function. For instance, 0 times 0.5 0.1 is equal to 0. 1.0.2 is 0.2. And then 2 times 0.3, we have, okay, 2 times 3 is 6. So 0.6. Okay, and this follows. 3 times 0.2, okay, that's 0.6. 4 times 0.2 is 0.8. Again, for your third column, just multiply the first and second column. Okay? For your fourth column, subtract the random variable to the mean. Okay? Again, you need to solve the mean first. That's why I presented the process on computing the expected value or mean first, because that will be useful to solve for the variance. So, what is our mean here? So, our mean in here, when you're going to perform the same process, you will have a mean of 2.2. Okay, 2.2. If you're going to consider this table, okay, just add that. Okay, and that will be your mean. 2 plus 6, 8 plus 6, 14 plus 8, 22. So, bring down 2, carry 2. That's why you have 2.2. So, what you're going to do with your fourth row, just subtract 0 minus 2.2, that's negative 2.2. 1 minus 2.2, that's negative 1.2. And then the same pattern. Okay? And for your fifth column, okay, the resulting answers in your fourth column, just square it, meaning multiply it by itself. Okay, multiply it by itself. Negative 2.2 times negative 2.2 is positive 4.84. Okay, let's have our last column. So what you're going to do is the previous answers, just multiply it to the probability function. Okay? Meaning, you are going to multiply this one to this one. Okay? And the resulting answer would be this one. So, what you're going to do is, since summation, you're going to add this one. 0.484 plus 0.288 plus 0.012 plus 0.128 plus 0.648, and that is equal to 1.56. Okay, that's why your variance here is 1.56. Okay? And if you are interested with, okay, if you are interested with the standard deviation, you will just, okay, get the square root of 1.56, and that is equal to, okay, equal to 1.25. Okay? And okay, you can state that therefore the variance of the given random variable is 1.56. Or if standard deviation is asked and the standard deviation is 1.25. Okay? Okay. So we will try this so that you can have your practice and for your mastery. When three coins are tossed once, the probability distribution for the random variable x representing the number of heads that occur, the number of heads that occur. Compute the variance and standard deviation of the probability distribution. Again, even though expected value is not asked, still you need to find it to solve for the variance and standard deviation. Of course, for your solution, of course, the same thing. Just copy. By the way, this is the given random variable and probability function. Just copy it. Okay. That's your random variable and then probability function. Again, what's the next? Okay, just multiply. That's correct. After that, what you're going to do? Of course, if you're going to add this, that will be your mean. Okay? And what's your mean in here? If you're going to add this. Okay, you have your mean as 12 over 8. 12 over 8. 12 over 8. What's 12 over 8? Divide by 4. Okay, that's 3 over 2. What is 3 over 2? That's 1.5. That's 1.5. Okay, your mean is actually 1.5. 3 halves. 3 halves. Okay, and you are going to square this one for your next steps. You have this. Okay, and finally, multiply this one and the given probability function, get its sum. You will have 0.74. Okay, and this will be your variance. That will be your variance. 0.74. And for your okay, standard deviation, we will okay, draw it correctly. Okay, for your standard deviation, just get its square root, which is approximately 0. We will write 0 0.86. Okay, and since we have answer all the requirements, so meaning that's it. And I hope you enjoyed and see you again for our next session.